Equals Math curriculum is unique in providing best practice math instruction found in general education to students with disabilities. It provides the means, support, and opportunities that elevate math instruction with higher expectations, creative adaptations, and connections to real-life problem solving in the real world. This can only be accomplished with meaningful lessons and the materials to provide accessible rigor and understanding. Teaching Equals Lessons requires a variety of materials: objects, cards, work mats, posters, and student tools. Each material used in the lesson is reused throughout the lesson and often in a series of lessons. What you will see are materials specified in the lessons and their use in a lesson component in 3 different lessons. Their use depends on the lesson components and, of course, what is taught in the lessons. In some lesson components, students watch a model as the teacher builds a concrete representation of the vocabulary word, then interact with it, explore lesson tools, or use tools and a strategy to solve a problem. Work mats help students manage their hands-on materials, and the Solve poster guides students as they watch their teacher solve a problem, and when they solve a problem with their group and on their own. Theme posters help students understand a particular people or animal environment to discover math is everywhere in our world, and to more easily solve a problem related to that theme. Within the Manipulative Kit, you will find items that can not only be used within the lesson itself, but also can be used to create an adaptation to support a student's independence. This webinar is a glimpse into how Equals Math materials are used with demos and real classroom videos. The first lesson you will see will be from Lesson 1C10. In Chapter 1, Section C, Lesson 10, the learning objective is student will identify 2-dimensional shapes, specifically a rhombus and rectangle. This review game comes from page 1 of the lesson, where we are building background knowledge with the students, preparing them for what is to come later in the lesson. Looking at the game, we will see that we need to prep by placing attribute blocks, 1 of each, circle, square, and triangle, a paper bag, and shape cards on the table. Then place environmental card choices, 2 of each, circle, square, and triangle, on the table in a horizontal row or on a chalkboard ledge. Then assign student pairs. There is also the option to include actual environmental shapes instead of shape cards. When the lesson begins, place 1 shape in the bag secretly. Each student pair then takes turns touching the shape in the bag without looking. They then choose a card with a similar shape. If they are correct, they keep the card. Play continues with the next student pair. The pair with the most cards after 5 turns wins.
Okay, so how about we split into 2 teams. Fahima, Baja, you can be on team 1, and Duretzi and Mohammed and Monafi will be on team 2. So,
2.
no one look. Oh.
Don't take it out. No.
This is what it is, right here.
Put it back in.
All right, guys. What shape do you think it is? Okay.
What shape do you think it is?
They think it's a square.
Can you tell the others what you think it is? Which one is it? Square.
All right, are you guys ready?
Yeah. Yes!
You were right. It was a square. Are you good? You got it?
Yeah.
Okay. All right, Mohammed.
Mohammed.
You got it? You think you know? All righty. You think you got it? Okay. All right. What shape?
A square.
What shape do you think it is, Mohammed? Choose one. A triangle or a square?
Ooh. Do you want to try more? Do you have to feel it more?
Do you want to try it one more time? You think you know? Yeah? Which one? Okay. How about you? Which one? A triangle or a square? A square. All right. Well, let's find out.
A square.
Square.
In Chapter 3, Section A, Lesson 1, the learning objective is student will compose and decompose sets of 2 through 5 and describe the parts in whole. The math dash also comes from page 1 of this lesson, where we are building background knowledge with the students, preparing them for what is to come later in the lesson. Looking at the math dash, the lesson states to show a rod with 5 connecting cubes. Say, I see a set of 5 cubes. Break off 3 and place them under the bowl. Put remaining 2 on top. Ask how many are hidden under the bowl. Reveal amount. Reconnect rod and count. Say the total is 5. Show subitizing card with 5. Cover 3 dots with sticky note. Ask, I only see 2 dots. How many dots are under the sticky note? Students answer and explore. Lift sticky note to show the part covered, 3 dots, and 5 total. Repeat with 2 through 4. Students explore. Ask open-ended questions, such as, after I joined parts, was the total the same as before? Students answer.
We start with 5.
Yep.
Separate and put 3 under the bowl. How many are under the bowl?
3.
3. How many do I have here?
2.
2. When? How many did we start with?
5.
5. Okay. I'm going to take these back out and we are going to join. How many do I have?
5 again.
Still have 5. Got it? Everybody good? Yeah, 5. Give me a high 5. Good job. All right. So, how many are here?
5.
5. See if I just touch 5. Very good. We have 5. Okay. Same as that. I am going to cover. I'm going to take this sticky note. I'm going to cover 3. How many are under the sticky note?
2.
How many are under the sticky note? How many are hidden?
5.
There's 5 altogether. How many are hidden? Thank you, Damien. There's 3 hidden. How many can you see? Let's count these 2. Ready? 1.
1.
How many?
2.
2. You counted 2. How many, Jabari?
2.
2. All right, when I reveal the 3 that we hidden, do you think we are going to have more dots, less dots, or the same amount of dots that we started with?
The same amount of dots. Same.
How many did we start with?
5.
All right, let's check it out. Ready? 1, 2, 3. Let's try again. Ready? 1, 2, 3. How many dots do we have?
5, man.
5. Do we have more than we started with, less than we started with, or the same amount?
The same amount, man.
Same amount. Awesome.
In Chapter 2, Section A, Lesson 8, the learning objective is student will count to 10. Think About It comes from page 2 of this lesson, where we are extending conversations from page 1, introducing new vocabulary, and solving two problems. The first problem is for the teacher to demonstrate solving the problem. Then the teacher and students solve the second problem together. Looking at Think About It, we will place the math line and step-by-step on the table. Record 1 through 10 on the step-by-step, then fasten 10 connecting cubes onto the math line. The solve poster is also used.
Alright, here's the problem. You guys listening? See it, Amir? I'll turn it for you guys to see it, okay? Ready? Mrs. Lambert is helping guests take turns on the water slide. She needs to count to 10 before the next guest can go down the slide. How does Mrs. Lambert count? How? All right. We are going to use our problem-solving method. All right? So, first step, facts. What do we know? All right, we have to find the facts. What facts? What facts? What's important to know about this problem? So, I know Mrs. Lambert needs to help guests take their turn on the water slide. The problem shows that she...
Oh, this works?
It's okay, Mac, we had to move it so we could see. That she counts, okay? Mrs. Lambert counts. What does she count to?
Count 10.
You guys see over there?
Count 10.
She counts to 10.
Oh my god.
Okay, so I know that Mrs. Lambert counts in number order. Okay, she's going to count in number order. She's going to count in number order to 10. Okay? All right, next step is our action. Or what can we do to solve the problem?
I know.
What do you know?
Solve the problem like some song says.
Yeah. I will count
To 10.
good job. I will count.
What does this mean? A count.
Yeah, that's the action. Our action is count.
I need that.
I want to know how to count to 10. Okay. Next step. Step 3. Estimate or prediction. Okay.
Estimate of the tornado.
Prediction. Yeah, Yanni, over here.
What is a tornado?
Could you leave it here?
But I mean, what is the board says? What it?
This is the problem-solving method. We're on step 3. Ready?
Why?
'Cause that's how it goes. That's how we're going to solve the problem.
What do they want?
All right, so I'm going to predict that I will count numbers
Lost again?
in order to 10.
Why?
That's my prediction. Thanks, Mac. Okay? So we're going to count number order up to 10. Step 4, tools and strategy. What strategy or tools can we use?
Oh my head.
First, I will use the math line.
The math one. Why?
Why? Because it's going to help us count to 10.
I'm
I'm going to use the math line. Kyle, watch.
Quiet now.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Nice.
And that's computer mind.
So we can use another math tool, the step-by-step, to help us count to 10. Badges, can you help us? Can you help us count to 10?
1, 2, 3, 4, 5, 6,
do 10. All right. Next step, the solution. How do we solve it?
Mrs. Lambert is not here today.
No, she's not. All right, so we solved the problem by using our math tools to help us count in number order to 10.
A 10.
To 10.
But this is not a 10.
In Chapter 1, Section D, Lesson 3, the learning objective is student will identify sets that are one and many in piles. Concrete, semi-concrete, and abstract, or CSA, comes from page 3 of this lesson and focuses on direct instruction of the lesson objective through the use of the CSA learning sequence. CSA is then followed by a skill worksheet. Looking at the CSA, we will show 3 views, concrete, semi-concrete, and abstract, to all students, using the student examples noted from Solve It Together first. Then we will use the examples provided below as needed to represent all 3. When finished, students will choose one or more representations to try. For concrete, we will hold up one finger. Say, "This is one finger." Show workmat 3 with a set of 1 cube and many cubes. Match one finger to set of 1. Next, we'll show many fingers, both hands with all fingers extended, and say, "These are many fingers." This is a set of many. And place both hands by the set with many. For semi-concrete, we will show the supertizing card for 1 and say this is 1. Show workmat 3 with a set of 1 cube and many cubes, then match the supertizing card to the set of 1. Next, we can show multiple supertizing cards and say this is many, and place the cards near the set of many cubes. For abstract, we will draw a circle on the board, draw one shape in the center, and say this is 1. Then draw a second circle on the board, draw many shapes inside, and say this is many. We can repeat the activity, let the students try it, then provide the skill worksheet.
1. Can you show me 1? Good. Show me 1. Show me 1. Show me 1. 1. 1. Yep. 1. How many? 1. How many, Evan? All right, and in this circle, can you see, Michaela?
Pegs.
We are gonna put
Can we take a pixel?
many. One. Put on. Where should we put that card? And where should we put many? Very nice. Good looking. All right, Ethan, are we looking? I have this circle and I have this circle. Are you ready to label?
Yeah.
Can you label the circle that has, what is that?
Many.
Many. Can you label the circle with 1? Very good. All right, let's label.
Hi.
Wow, nice talking. Very good. Next one. Love it. Circle the set that has many. Circle the set that has many.
Has many.
Circle
Did you do number 1? Can you circle the set that has many?
Look. Many. Which one has many?
Use your pencil.
This one.
Which one has many?
This one. This one.
Evan. Number 2.
Which one has many?
Do number 2.
The Equals curriculum comes with a variety of manipulatives to support all 444 lessons. These manipulatives are used strategically throughout the curriculum to provide consistent support, while offering unique activities and experiences that keep students actively engaged in lessons. For more information on the Equals Mathematics curriculum, visit www.ablenetinc.com